Okay, so we're not going to start really getting into proofs until next week, but today I want to kind of just go over some basic intro things that will make it easier for us when we start doing proofs. So I want you to make sure that you write down all of the theorems and postulates that are in 2.6 and 2.7. All right, so please make sure that you do this as part of your assignment today. You don't need to post that, but just make sure that you've got that written down on your theorem postulate sheet by Monday. All right, so then for the rest of today, there's some definitions that are within 2.7 and even a couple of theorems that I want to talk to you just so we've got a good understanding of what some of these things look like. That when we jump into proofs, we can just jump right in. So the first thing, we're looking at page 90. The first definition I want to go over is the definition of a linear pair. So a linear pair is a pair of adjacent angles whose non-common sides form a straight angle or a straight line. So for example, that would look like this. If I can draw straight lines today. So let's say that this is angle 1 and this is angle 2, right? So these two angles come together. So remember, adjacent angles are two angles that share a common side, but they don't overlap, right? So angle 1 is here and angle 2 is here, right? So they're adjacent, they don't overlap with one another. But then they're not common sides, so the sides that they don't share, right? They share this side here. But they come together to form a straight angle or a straight line, right? So we've got a line here, and then it's like divided up into two angles. So that is what a linear pair looks like. The next definition I want to go over is vertical angles. So vertical angles are a pair of non-adjacent angles that are formed by two intersecting lines. So let's draw our two intersecting lines. Let's make them yellow. All right, so let's think about what we've got going on in this picture. So non-adjacent angles means that they can't share any common sides. So like these two here are adjacent, these are adjacent, these are adjacent, and these are adjacent. So for them to be non-adjacent, they have to be kind of like opposite of one another. So let's number our angles. Let's say we have 1, 2, 3, and 4. So like angles 1 and 3 would be a pair of vertical angles, as well as angles 2 and 4. So they're angles that are across from one another. Right, and then in this section, there's the vertical angle theorem that says all vertical angles are congruent. So that means that the measure of angle 1 is going to be congruent to the measure of angle 3. So any pairs of vertical angles are going to be congruent to one another. So like 2 and 4 are going to be congruent. So that means if this is 35 degrees, this is 35 degrees. They will be exactly the same. All right, and then the last thing that I really want to talk about is complementary and supplementary angles. So complementary angles are two angles whose measurements add up to 90 degrees. And supplementary angles are two angles whose measures add up to 180 degrees. And then some of these theorems, real quick, that we'll just kind of talk about. So if you look on page 90, there's the linear pair theorem. And that one just says that angles that form a linear pair are supplementary. So they're going to add up to 180, which makes sense because a straight angle is 180 degrees, right? So if we're just splitting that into two angles, those two angles would have to add up to 180. Then we have if two angles are adjacent and supplementary, they form a linear pair. And really, that's just about it. So on page 92, I want you guys to try your best on 1 through 12. I think really on 1 through 5, you will do just fine. Try your best on 6 through 12. We'll see how we do. And then we'll check those together on Monday, and then we'll really jump into proofs.